Let's look at OpenStax College Physics, Chapter 11, Problem 33. Suppose you measure a standing person's blood pressure by placing the cuff on his leg 0.5 meters below the heart. Calculate the pressure you would observe in units of millimeters of mercury if the pressure at the heart were 120 over 80 millimeters of mercury. Assume that there is no loss of pressure due to resistance in the circulatory system, a reasonable assumption since major arteries are large. So here we have a happy guy whose blood pressure is getting taken in the leg. So here is his heart. The leg is half a meter, the cuff is half a meter below the heart. And if we know that the pressure at the heart is actually 120 over 80, we want to know what the pressure is below, half a meter below the heart. So let's write down the things that we know. We know that the height difference is 0.5 meters. And we know that his blood pressure is 120 over 80 millimeters of mercury. So we're looking at the blood pressure in the leg. All right, so we have to consider here that pressure changes with depth, or changes with height. So we have pressure at the leg level is going to be equal to pressure at the heart level plus rho g h. Now, there are several things to consider here. One is the density of blood, which is given in a table to be 1.05 times 10 to the third kilograms per cubic meter. They're just a little bit more than density of water. And if we multiply density in kilograms per cubic meter by g as meters per second squared and height in meters, this quantity will be given to us in newtons per meter squared or pascals. We're given the blood pressure in millimeters of mercury. So to simplify this solution, so we don't have to convert so many times, I can just find the change in pressure between the level of the heart and the level of the cuff here. So if I find that difference, then I can just convert the difference and only have to do that once. So let's find this difference. So delta P is P at leg level minus P at the heart level. And that will be 1.05 times 10 to the third kilograms per cubic meter times 9.8 meters per second squared times the height, and that's 0.500 meters. So the difference in pressure is 5145 pascals. Now, I can convert that from pascals into millimeters of mercury. So I know that 1 atmosphere is 760 millimeters of mercury, and 1 atmosphere is also 1.01 times 10 to the fifth pascals. So when I multiply these through, I get 38.7 millimeters of mercury. So what this says is that the change in pressure between the heart level and the leg level is 38.7 millimeters of mercury. So there's more pressure at the leg level, 38.7 millimeters of mercury, more at the leg level than it is at the heart. So then we add this pressure difference to both the 120 and 80 and end up with blood pressure at the leg level being 120 plus 38.7 over 80 plus 38.7, and that's about 159 over 119 millimeters of mercury. So the guy has hypertension in his leg. Not really. It's the same blood pressure It's just that it's not measured in the correct place.